Morning, students. In last lecture, we understand some important things about the current carrying wire. We know that if we place a compass needle near a current carrying wire, it experiences a force due to which it deflects. Why it deflect? Because we know that this current carrying wire produce a magnetic field around it, and this magnet is also have a magnetic field around it, and these magnetic field interact with each other, and due to which this compass needle deflect. Okay, now what will happen if this wire is free to move? We know that according to Newton's third law, every action has equal and opposite reaction. If this wire exert a force on this compass needle will also exert some force on this wire, due to which it can also move. This is called the force. It means by the interaction of this wire, which produce a magnetic field around it, and the magnetic field produced around this magnet, these interaction produces a force on this magnet or on this wire. In this video, we will try to understand the force on the current carrying conductor in a magnetic field. What will happen if we put a current carrying wire in a magnetic field? Since this current carrying wire also produces a magnetic field around it, and magnet has also its own magnetic field. These magnetic field, due to the interaction of these magnetic field, this current carrying wire experiences a force. And in the activity in NCERT book, we will try to understand how this force is exerted on this wire. This is an activity in NCERT book. You can write the heading of this activity. This is activity to show that how the current carrying wire experiences the force when it placed in a magnetic field. This is the stand, and we are hanging a wire by this stand. This wire is of aluminium wire. We are using aluminium wire because we know that aluminium is a good conductor of electricity. Now this wire is connected with the switch and the battery, and we can hang this wire. Okay, we can hang this wire AP like this. Now place a magnet, a U-shaped magnet, or we can say the horseshoes type of magnet, like this. It is the N pole of the magnet. We know that all the magnets have the N and S pole. This is N pole of the magnet. This is the S pole of the magnet. This setup is like this. This is the rod. This is the AB aluminium wire, and this is the magnet. So we have to put a magnet like this. Okay, this like this. This is the wire and this is the magnet. By switch on, we know that the current will start to pass through this wire. So this is the positive and the negative terminal. The current will passes from B to A. We saw that if we start to pass a current in this wire, due to magnetic field produced by this wire and this magnet, this wire experiences a force. Since this wire is free to move here and there, it moves in this direction, in left direction. And what happen if we reverse the direction of current? By reversing the direction of this battery, by make it reverse, like positive idhar kar diya, negative idhar kar diya, then we saw that by reversing the direction of current, the force exerted on this wire is also reversed. First अगर ये ऐसे मूव कर गया था, जैसे ये है, ये आपका मैग्नेट है, दिस इज द वायर. जैसे आपने करंट पास किया, it move in this direction. This is the left direction. And what happen if we reverse the direction of current? It move in opposite direction, opposite to the first one. It means by reversing the direction of current, the force exerted on this wire is also reversed. Again, if we don't change this arrangement of battery and we reverse the direction of this magnet, what will happen if we reverse the direction of this magnet? Suppose N pole is in the upward direction and the south pole is in downward part. Then the force exerted on this wire is also reversed. same as if this wire is moved first case, if this wire is moved in this direction, again after reversing the pole of the magnet, this wire is moved in opposite direction. On two factors this force exerted on this wires depend. It means on the direction of current and the direction of magnetic field. We all know that the direction of magnetic field in a magnet is from north to south direction. So by reversing the direction of magnetic field or by reversing the direction of current, we can reverse the direction of force exerted on this wire. You can also write the activity. You should write an activity to show that a current carrying wire experiences a force when placed in magnetic field. I explained you that why this force is exerted on this wire, because this wire also this wire is also produce a magnetic field around it, and this magnet is also have a magnetic field of its own. These magnetic field interact with each other and they produce a force on this wire, and this force is maximum if we place this wire vertical to the magnet. This is the vertical. In vertical direction, it experiences a maximum force on it. Now, the direction of this force we can find by using Fleming left-hand rule. Now, you can write the Fleming left-hand rule. I will explain you what is Fleming left-hand rule, and then we will write the Fleming left-hand rule. Fleming's left hand rule. What is Fleming left hand rule? This is my hand. Stretch your finger like this. All your fingers like this. They are all perpendicular to each other. This finger is perpendicular to this one. This finger is perpendicular to this one. These are also perpendicular to each other. So stretch your finger like this. They all are perpendicular to each other. Your forefinger, middle finger and your thumb. Okay. Now stretch your fingers. Your forefinger, your middle finger and your thumb are perpendicular to each other. Then your middle finger show the direction of current. Your forefinger show the direction of magnetic field. You can write B. B means magnetic field in your finger. You can write here I. I means current. Then this thumb show the direction of force exerted on the wire. This is the Fleming left hand rule. We can apply this rule to find the direction of force exerted on this wire. So you can move your hand in any direction like this. You can move your hand in any direction. To place your hand in the direction of this activity, like current is moving from B to A. This is the direction of current. Now the direction of magnetic field is from north to A, north to south. North to south means if this is the direction of current, then you know that मैंने ऐसे रखा था ना, इसको ऐसे रखा था, है ना, ऐसे रखा था, means नीचे है ये. A figure I can't make a 3D figure, so you have to understand by this figure only. This is your hand and this is the direction of current. And this is the direction of magnetic field. There is much less here in this. There is a much less space here. Okay, this is the direction of current. Okay, and your finger show the direction of magnetic field. So your thumb show in this direction. This is the direction of your left side. This left side is the direction of force exerted on this wire. You can make a figure like this, like your hand. This is your forefinger and this is your thumb and this is your middle finger. You can make a much better figure than me. Okay, like this. Fatty hand. This shoe. This finger show the direction of magnetic field. This finger, middle finger, show the direction of current, and this thumb, this is perpendicular to both the fingers, show the direction of force exerted on this wire. Okay. Now this is the Fleming left hand rule. By using this rule, we can do. By using this rule, we can find the direction of force exerted. Direction of force exerted on the wire by the magnetic field, by the magnet. This type of means such a force which is exerted on this wire is used for preparing motors, electric motors, electric generator, even loudspeaker, microphone. In such an instrument, we use this principle. The principle is that when we place a current carrying wire in a magnetic field, it experiences a force. We can use this force in making many instruments like the electric motor. Okay, one question from NCERT book. This is a question of NCERT book. An electron. Okay. First of all, I have to explain some points. You should remember these points. First point is this: the direction of current. The direction of current is in the direction of positive charges. It means in a particular question, if it is written that the positive charge is moving from here to there, it means this is the direction of current. So the direction of positive charges were taken as the direction of current. Second point is this: the direction of current is in opposite direction to the direction of negative charges. If in a particular question it is written that the negative charges, like the electrons, are moving from this point to this point, it means we will say the current will move from B to A. Okay. Now the third point: the direction of deflection. Direction of deflection show direction of force. Okay. Sorry, I forget to write the Fleming left hand rule. Write the Fleming left hand rule. Fleming left hand rule is this: stretch your left hand. Stretch your left hand fingers, that is thumb, forefinger, and middle finger, in such a way that they are mutually perpendicular to each other. Mutually perpendicular to each other. Okay, like this. These all fingers are perpendicular to each other. If the forefinger point in the direction of magnetic field, middle finger in the direction of in the direction of current. This middle finger show the direction of current, like in this figure. This is the direction of current, this was the direction of current, this is the direction of magnetic field. The force, the thumb show the direction of force. Okay, then the thumb will point in the direction of motion or force acting on conductor. This is Fleming left hand rule. You should learn this rule. Now we are going to do some questions of NCERT book. First question is this. This is the example 13.2 of NCERT book, page number 231. This question is this. An electron enter a magnetic field at right angle. This is the direction of magnetic field. Okay, this is direction of magnetic field. You know, we show the magnetic field by this finger, as shown in this figure. And this is the direction of electrons. I've already told you the direction of current is opposite to the direction of negative charges. It means negative charges moving from this point to this point. We will say the direction of current will be from here to there. The direction of force acting on the electron will be. Now you have to find the direction of force exerted on this electron, this beam of electron. Now by using your left hand rule, you can find the direction of force. Okay, आपको रट्टा नहीं लगाना है. You have to use your hand by Fleming left hand rule. This is the direction of magnetic field. Okay, this line show the direction of magnetic field. Now this is your middle finger. This show the direction of current. Now the direction of current is in this figure is from here to there, because the direction of current is this one. और आपको पता है डायरेक्शन ऑफ करंट इलेक्ट्रॉन्स के करंट का अपोजिट होता है. तो डायरेक्शन ऑफ इलेक्ट्रॉन्स अगर ये है तो करंट का डायरेक्शन ये है. यू कैन मूव योर हैंड इन एनी डायरेक्शन. ओके, फ्लेक्सिबल हैंड यू हैव. तो दिस इज द डायरेक्शन ऑफ मैग्नेटिक फील्ड, this is the direction of current. So your thumb show in downward direction. This downward direction is the direction of force exerted on this electron. Okay, so this is in the downward direction. We find it by using Fleming left hand rule. One more question of NCERT book. This is the question number 3 of page number 232. A positively charged particle. मैं आपको पेज नंबर इसलिए बताती हूँ ताकि आप उस क्वेश्चन को पढ़ सकें. ओके, A positively charged particles projected towards west is deflected towards north. This is the east, west, north and south. We know that the direction of east, west, north, south is always in your notebook is like this. The positively charged particles projected towards west is deflected towards north. It means the alpha particles, the positively charged particles, are moving in this direction. This is the direction of positively charged particles. We know that the direction of current is same as the direction of positive charges. So we can say the direction of current is from here to there, from east to west. It is deflected towards the north. The force exerted, it means this is if they are deflected towards the north, it means the direction of force is towards the north. This is the direction of force and this is the direction of current. Now you have to find the direction of magnetic field. By using this law, the Fleming left hand rule, we can find the direction of magnetic field. This is the direction of current. You can move your hand like this. Force is like this. Okay. This is the direction of this is the direction of current and this is the direction of force. So this will be the direction of excuse me, this is like this. This is the direction of magnetic field it means in the upward direction. This is the direction from south to north, direction of force, this direction of current from east to west. So the direction of magnetic field will be in the upward direction. So your hand is free to move in any direction. You can use this hand to find the direction of force, direction of current, or the direction of